Hey there, Lot.
Hi,
How are you?
I'm good. How are you?
Good, 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 good. Um, so are we still, what are we doing?
Well, I got my mocks back today.
How,
Um,
and
so the good news is I got a 5 on paper 2, but the bad news is I got a 2 on paper 1.
that is amazing. The 5.
Yeah, the 5 is good. I'm happy with the 5. To be fair, okay, so the teacher said the exam was the hardest he's ever seen for SLs. So he's brought the mark up to what he thinks the IB criteria would be now. But for the paper 1, I got 4 out of 72 marks. Yeah, which is absolutely awful, obviously.
What did you misspell your last name so you only got 4 for your first name? Is that what happened?
No, that's not how that went, unfortunately.
Listen,
So,
I took a thermodynamics test in college in engineering. So that it's a string of courses, statics, which absolutely killed me.
Yeah.
Somehow I dragged myself back from the dead and took dynamics. That
Okay.
killed me in a grisly fashion.
Okay.
Again, I must be a vampire. Thermodynamics. I walked in, 3-question tests, and I went,
You just don't know. Yeah, that was math.
I put it in my book bag, waited till the end of the test because I was too embarrassed, walked out and decided I wasn't going to be an engineer because I hated it anyway. So
That
anyway, you're not alone. Everybody needs one of those.
Yeah, of course. Yeah, honestly, I know I didn't study, so it's up to me, which I know I can do, so it's fine. I think I can bring it up. And on average, that's a 4, which I can survive with that for my conditional offers, so that's okay.
Sweet.
Okay. Yeah.
Okay.
So for today,
you're gonna send it to me?
I can. Would you like me to just send pictures of it?
Is that what you want to do today?
We're going through it in class, so I don't know if that would be good because we've done most of the questions.
No, don't send it unless you know.
Yeah.
You can send it if you ever want to go over it. So go ahead.
Yeah, maybe if I don't get it, but I honestly think I just need help with like functions, just simplifying them, just all of that stuff, just functions. That's why paper 1 is so tough for me, is because it's just the basic algebra 2 stuff that I can't do.
Which is weak for you.
Yeah, that's my biggest problem. It's just algebra 2 stuff. So just functions. That's literally it. I don't know if that helps you at all, but
to give you function questions. You don't have any specifically?
No, because we haven't done functions since 2 years ago.
We can totes do that. And yeah, I said totes. So what?
Yeah, so what?
No cap. Here he goes.
Okay.
Here he goes. He's on fire. All right. IB test bank. There it is. I'm kind of illegally in the test bank, but not really.
Okay. That's okay. I won't tell.
Actually, I don't know if I'm at fault or if, so my old school, I have, good friends there and they granted me access. So
great.
I'm sort of complicit, right?
Right. You're just a bystander. You didn't do it.
Well, but there's still criminality there. Like if you're at the scene of a murder,
right,
and you're, and you can be charged with murder. I don't know why I'm going down this road. I'm sorry.
You're gonna put this on YouTube. Be careful. IB might come for you.
Partha,
don't tell.
Don't tell. Zip it.
He's good. He's good at keeping secrets. Don't worry.
I know where you live, Parpa.
He does.
Partha.
I sent him your address, Partha.
Ooh, all right, now we're totally in the creepy part. I'm afraid of Partha.
Me too. Most people
Because
are.
Partha's a dude, right?
Yeah.
And he's what, 17?
Yeah.
Okay. Any dude 17 could whoop me without even trying.
No, he's harmless. He's harmless.
You have no idea how many things I have the matter with me. I have over 40 something pieces of, are you ready? Titanium in my elbow.
Oh my God.
Yeah,
What?
I know. Yeah.
Ouch. Ugh. Does it hurt or is it just like a joint replacement?
Well, I shattered it because I was trying to be like you cool kids and ride one of those motorized scooters in downtown
Oh.
Indianapolis.
Okay. Yeah.
Right. And
Yeah.
didn't see like a pothole and did a triple backflip and
Ouch. Oh my
shattered
God.
my right elbow, and 3 surgeries later, here we are.
Ouch.
I'll show you
Sorry.
pictures later.
Great. That sounds really painful.
It was.
Yeah. I've never broken a bone or chipped anything.
I hadn't
Boring.
either. It was a couple years back,
Fair
so I
enough.
was like, what, 52? I thought
Mhm.
I thought I'd made it, like, all right.
Yeah.
Nope.
See, this is exactly what I can't do.
Well, neither
Like all of the
neither
G of
can
F stuff.
neither can I. So maybe between the two of us, we can figure out what the heck's going on.
Okay.
We should pipe
Yeah.
Partha in too.
Yeah.
All right.
Okay.
So this is a composite function,
Mm-hmm.
meaning it's a function within a function.
Okay.
I don't like this notation. I prefer to rewrite it, and this is the way it's said anyway.
Mm-hmm.
G of f of x.
Okay.
Okay. Well, G of f of x. Now, if I just as a starter, if I said find G of 3, forget about everything else. What would you do to find G of 3?
8 times 3 plus 5.
You would replace
Which
the
is
x with
20.
3, right?
Yeah. 29.
And then off you go. Well, this is asking G of f of x, right?
Mm-hmm.
So that means I take G, which is 8x plus 5, and I replace the x with f of x plus 5.
Okay.
Well, what's f of x?
X plus 3 over 4.
You see anything I can do with that 8 and 4?
Yeah. Divide by 4.
Yes.
Mm-hmm. See, that's the thing. That makes sense, but in an exam, I would never do that.
Do what? The cancellation?
Yeah. It would never come to mind.
Well, now it does.
Now it does. Yeah.
Okay, so let's just do, maybe you wouldn't see the cancellation. That's fine. So 8 over x or times x plus 3 over 4, right?
Yeah.
Do you see that that's equal to 8x plus 24 over 4?
Yeah.
Because that's really 8 over 1.
Mm-hmm.
Do you need the 1, or do you immediately know that you can do this?
I would know. I think I would know. And that makes it easier. Yeah, I would be able to do that.
And that this is the same as 8x over 4 plus 24 over 4?
Yeah.
Which is 2x plus 6.
Okay.
Yes?
Yeah. Cool.
No shame in that. We'll just don't let Partha know that you're going to do that. Okay. So All right, let's just write this. G of f -1 of a is equal to 4. Yes?
Yes.
Do you know what this -1 means?
No.
Okay, it means the inverse of f.
Okay.
I'm thinking of the best way to do this. I apologize, it's not f that's the inverse. It's the whole thing.
Okay.
Okay, all right, so this is, so do you agree that g of f of x
It's 2x plus 11.
is equal to 2x plus 11? Is that fair?
Yeah. Yeah.
Okay, do you know anything about inverse functions?
No.
All right, here we go. And this is not because of your current teacher, this is just your previous mathematical experience.
Yeah, this is from Florida.
Florida?
Yeah, I kind of Florida wasn't my prime, so I didn't
Did
really
I
learn
hear this?
anything.
Have I heard this? Where in Florida?
I was in Jacksonville for a year.
That's right. And what school were you in?
Episcopal?
Private.
Mm-hmm.
And math was no good there.
Math was no good, but I also was no good. So I kind of
I
just,
just can't imagine it.
yeah, I didn't understand the thing that happened in algebra 2. So, but that was
Inverse
also
function.
kind of because I didn't learn algebra 1.
And who's to blame for that?
Me, because I skipped it.
Jacksonville?
Nope,
You
UK.
just didn't do it.
I just didn't do it.
That's tough. Okay, inverse functions.
Yes.
Okay, I'm not going to get all mathy.
Okay.
You take a function and switch the x and the y.
Okay.
This is then the inverse of the function. Okay.
Okay.
So let's consider f of x equals, for example, 2x plus 11. Let's call it h of x because that's actually the composite function, right? F of x is something else. So h of x, which we know is the inverse, whatever, h of x is equal to 2x plus 11. Now, this function notation is another way to write y. Y equals 2x plus 11. Am I right?
Yeah.
Okay. So this is the function. Its inverse What do we do to find the inverse?
X equals 2y plus 11.
Yes.
Okay.
And then we solve for y. Because
Yeah.
that's how we list functions, right?
Okay.
So we would have what? X minus 11 equals 2y. X minus 11 over 2 equals y, right?
Yeah.
So we say that the inverse of h is x minus 11 over 2. Is that okay?
Okay.
So let's plug in a point here for this one. So choose your favorite integer.
1.
Good. It's the loneliest number, I hear.
Yeah.
2. So that would, if I plug in 2 or 1, what do I get for y?
3.
3, right?
Mhm.
Now, for this one, I'm going to ask you to plug in 3. No, I'm not.
-4.
What just happened? Oh, this is 11.
Oh. Oh yes. Okay.
13.
Yeah.
It is 11. Oh, so then this, did I do this right?
Yeah. I think so.
Okay, 11. So now I'm going to ask you to plug in.
Wait, is the answer not? Isn't it 13 for y?
What? 13.
Isn't the y
Yes.
coordinate? Yeah.
Yeah.
Okay.
God almighty, you need a better tutor. Okay, so now we're going to plug in 13 for the inverse. Yes?
Okay.
What do we
Okay.
get?
1. Whoa. That makes sense.
Yes, because to find the inverse of a function, you switch all of the x and y coordinates.
Right. Cool.
So they correspond, yes?
Mhm.
Isn't
Yes.
this fun?
Yeah.
All right, so g of f of x equals 2x plus 11, right?
Right.
You with me? Or
Yes.
we're just going to, this whole big giant mess, we're going to say y equals 2x plus 11.
Okay.
Just for now. Then we're going to find the inverse of this stupid. And then for this, we would, this notation, we would say this, the inverse, whatever. Okay. So I'm going to find the inverse of that, right?
Mhm.
So that means I'm going to say x equals exactly what we just did before, right? So we get y equals x minus 11 over 2, or g, the inverse of g is equal to x minus 11 over 2, right?
Mhm.
You okay with
Yeah.
that?
Yeah.
Now they tell us that the inverse of a is equal to 4.
Okay.
In other words, when we plug in a,
Yeah.
the result is 4.
Okay.
So x, or not a, x, a minus 11 over 2 equals 4.
Right.
A minus 11 equals 8, multiplying both sides by 2.
Mhm.
A is equal to 19.
Cool. That makes sense.
Okay?
Yeah.
You learned some function nonsense. How about that?
Yeah.
Okay. Nope, we're not going to do trig with it. Nope, we're not going to do that. Okay, let's keep doing these composite functions, okay?
Okay.
until you tell me to stop.
Okay.
Do you know what that capital R means?
My teacher told me to ignore it today.
For the most part, it's true, but it can become a problem, but it stands for the real numbers,
Okay.
meaning the real numbers are every single number on the number line. Nothing's left out.
Except, oh, so none of the I things.
That's not on our number line. That's
Okay.
that's a whole nother system, right?
Okay.
Okay,
Yes.
whatever. And you can't ignore it almost always.
Okay.
F equals, given that f of g of 2 equals -3 and g of f of 1 equals 5, find the value of A and the value of B. All right, so let's find f of g of 2. Want to?
Yeah. But we know it's -3.
Yes, right?
Okay.
So, well, first we need to know what g of 2 is, right?
Mhm.
G of 2 is equal to 2a plus b. Are you with me? Because g of x
Right. Yeah. Yeah. I see.
equals ax plus b, right?
Yeah.
Okay. So f of g of 2 is equal to, now I'm going to write f of x up here. It's equal to x minus 2, right?
Right.
So that equals g of 2 minus 2, which equals 2a plus b minus 2.
Mm-hmm. Okay.
And we
So we
also
just
know that
plugged.
f of g of 2 is equal to -3, don't we?
Yes.
Okay, so now we have -1 equals 2a plus b.
Okay. And we
Can't
just
solve
plugged
it.
into because we wanted to.
I'm sorry?
We just plugged into because we wanted to.
I
Or
don't know. I
because
don't know how to answer that. Because we wanted to, you mean just for fun? I'm
or
not being a smart
we
aleck.
plugged into because f of g of 2 is -3. So we plugged it also. We also plugged 2 into.
Yes.
Yeah, I get it. Okay.
G
Yeah.
of 2. Yes. Yes.
Okay.
Okay. So now I have an equation that includes a and b. Unfortunately, there's
Mhm.
2 variables, so I can't solve for
Yeah.
a or b. Yet, we also know that g of f of 1, g of f of 1 is equal to 5, yes?
Yeah.
Okay, so let's go ahead and do g of f of 1. Sure would be nice to know what f of 1 is. We do.
Mhm.
F of 1 equals 1 minus 2 equals -1, right?
Right.
Okay, so first I'm going to plug g of f of 1 into g of x. So do you agree that that would be equal to a times f of 1
Mhm.
plus b, right?
Right.
But f of 1 equals -1, doesn't it?
Yeah.
And we know that g of f of 1 is equal to 5, don't we? From right
Yeah.
here. So then 5 equals -a plus b, right?
Yeah.
Okay, so now we're good because I have 2 equations and the same 2 unknowns, we call them.
Mhm.
And so I have a system of equations, which is -1 equals 2a plus b. And usually we stack them, that's why I'm doing it, equals -a plus b.
Okay.
Do you know how to solve a system of equations?
Are you able to get rid of the b?
The b as in boy?
Yeah. I don't
How
know.
would
I
I,
don't remember.
there's three ways to solve a system. You can graph each equation and find where they intersect. This
Mhm.
is paper one, so no. You can use the elimination method, which is what I think you just described, because yes, we could get rid of the b if I take the first equation and subtract the second equation, because then I would have b minus b is 0.
Okay.
Does that sound familiar at all?
Somewhat.
The other thing I could do is substitution,
Okay.
where here, let me do this and then I'll show you the other way too, because we are trying to get you up to speed on algebra, so it's worth the time, right? This is called elimination. Like if I can do this and like combine, like if this was already a net minus b, I wouldn't have to subtract, I would just combine them.
Okay.
And the b minus, it would go away, right?
Yeah.
So -1 minus 5 is -6, yes.
Yeah.
2a minus a negative a is a 3a, yes. B minus b is 0. I'm going to write it just because this is the first time. Normally we wouldn't write it. -6 equals 3a. -2 equals a.
Okay.
And now I have two equations that relate a and b, right? So I can choose either of them. I'll just choose this one. It doesn't matter which one. And I know that -1 equals 2a plus b. But I also know that a equals -2. -1 equals 2 times -2 plus b.
Okay. That makes sense.
Yes?
Yeah.
And you really do need to see this other method.
Okay.
I wanted to make it red, just so it's awesome. Okay, so let's do this again. -1 equals 2a plus b, and 5 equals -a plus b. Okay, so I'm going to call this equation 1. Okay, and what I'm going to do with equation 1 is solve for b by subtracting 2a. -1 minus 2a is equal to b, right?
Yeah.
Now I'm going to bring in equation 2. I'm going to rewrite it just for fun. 5 equals -a plus b. Wait a second. B equals -1 minus 2a, doesn't it?
Yeah.
So that means I can substitute it into equation 2 for b.
Okay.
And now I have 5 equals -a minus 1 minus 2a. Or 5 equals -3a minus 1. 6 equals -3a. What? -2 equals a. And then we're back in business, right?
Yeah.
Bring this down. -1 equals 2a plus b. Plug this in. -1 equals 2 times -2 plus b. -1 equals -4 plus b. 3 equals b.
Okay.
So that's the substitution method.
Right.
So whatever floats your boat.
Okay.
The substitution method is best when you have a variable that only has 1 as a coefficient, because it's very simple to solve for it then.
Okay.
If you had like a 3b, and a 2b, you can still solve for it, but then you would have to, once you get everything else on one side, you would have to divide everything by the 3. or the 2, right? Which can be problematic if we're going to get fractions, and we know how you hate fractions. Am I right?
Right.
Okay. All right. Okay.
Yeah. Okay.
All right. That was fun. All right. I apologize in advance.
Okay. Okay.
Oh, was that an oi?
Yeah.
Nice. Solid use of oi.
Yeah.
Following diagram shows the graph of this horrificness. You okay with that?
No. I don't know where I would begin.
This is a whole lot to unpack, but it needs to be unpacked.
Yeah.
So basically, when we have transformations of functions,
Mhm.
we have what is called the parent function.
Yeah.
Okay. And it's the easiest function.
Okay.
That's why it's called the parent function in the family. So the parent function for this is simply the square root of x.
Mhm.
Okay. Because this is still the square root of x, but there's this other crap in there, right?
Yeah.
All it means is the shape of a parent function is the shape of a transformed function
Okay.
that uses its parent. Is that okay so
Yeah.
far?
Yeah.
Okay, so you would have to know this, or you would have to quickly be able to sketch it, the parent function.
Okay.
Okay, and the parent function, the square root of x. Actually, let's think about this. Y equals the square root of x, right? Do you know how to graph by just choosing points and plugging them in?
Yeah.
Okay, so what would be a good choice for the square root of x
4.
to graph it?
4.
4. Okay, so when x is 4, y is 2. Is that fair? So
Yeah.
we got that guy going for us. What else?
Just 1.
Ooh, look at you go. Good, because the square root of 1 is
1.
1.
And
How
what
about
is it?
0?
0 as well?
Yeah, 0 is the square root of 0 is 0, right? Okay, and why don't we go 9? So maybe here,
9. Yeah.
3. Okay, so this is the basic shape of y equals square root x.
Right.
Okay, and you can see by my outstanding drawing that it's generally the same shape.
And it wouldn't go further than 0 on the x-axis?
Why not? Yes, why not? Because here is -1. When x is -1, what's y?
Not possible?
Not possible in the real number system, correct.
Okay.
We're in the real number system. Okay?
Yeah.
Okay. So they're saying the question then, this horrible question is, what can we do to this? Severe thunderstorm warning. It expires in 8 hours and 23 minutes. Okay, so did you hear that?
Mm-hmm.
Okay,
Yeah.
that's what it was. So how did we get this to look like this? Well, we put a +3 under the square root, we put a negative in front of it, and we subtracted 1 from it.
Subtract 1 means go down 1 on the y-axis, no? I knew that.
What does the minus in front of the function do to it?
Does it flip it
Yes, over what?
over the x-axis?
You got that right. And what does a +3 with the x do?
Does it widen it?
No, you're
Okay.
thinking about a coefficient, like
Okay.
when you multiply the x by something.
Mm-hmm. But I don't know.
Okay. Well, what did -1 not doing with the x? What did it do? It moved it vertically,
Mm-hmm.
didn't it? You told me it
Yeah.
moves it down 1, right?
Oh, so horizontally.
Horizontally, yes.
And it's the opposite when it's with x, so it's gone left 3. Okay. Yeah, it's coming back.
I say la, you say la. See, that's a cheer for lots.
Mm-hmm.
The second part's hard. All right. So that's what they're asking, right? So describe a sequence of transformation. So it would be, for A, it would be reflection, or I would say flip over or in x-axis.
Mm-hmm.
Yes.
Mm-hmm. Yeah.
B, shift left 3 units. C, shift down 1 unit. Done.
Done.
Same exact things happen for any other function.
Okay.
Any other function. And another function that you're going to move around is y equals x squared. That's a parent function. Do you know what y equals x squared looks like? Good, it's a parabola, except it hits the origin. Sorry.
Okay.
They move this guy around a lot.
Okay.
All right. Okay. State the range of f. What does range mean?
The largest value minus the smallest value, but don't you have to do the brackets thing with the infinity signs and the
I didn't catch what you said at first, but I think you're right. The
like
largest
you
what?
do -3 comma infinity. No?
Okay, so you chose -3. That's the x coordinate. Range is y coordinates.
Okay.
But
So
if
it's
you
not
were
-3.
asking, if you were being asked for the domain, absolutely it would be -3 to positive infinity, because we're starting at -3 and moving to the right. Is that why you chose it?
Yeah.
Excellent. So what would the range be?
You start with the negative, no? So negative infinity.
Nope, you start from greatest to least.
Okay.
Left to right,
So then
top to bottom.
-1 to negative infinity.
Good. Why did I use a bracket?
Because it's included.
And is infinity ever included?
No.
No. Why not?
Because there's no end to it.
Right.
So
And then
yeah,
it's actually not a number, it's a concept. How about that?
Mm-hmm.
All right. Woohoo! Killing it.
Yep.
See. Find an expression for the inverse. Oh my goodness. So f of x is equal to -1 minus square root x plus 3. Say yes.
Yeah.
And because we're going to do the inverse, I'm going to just rewrite it with the y. Maybe you need to do that. Maybe you don't. I don't know. That's up
Okay.
to you. So the inverse of f, what are we going to do?
X equals -1 minus square root of y plus 3.
Now we got to solve for stupid y. What do you want to do?
Can we do x squared equals -1 minus y plus 3?
Well, that would mean you're squaring both sides of the equation, right? And if you're going to square both
Oh,
sides
you
of
did
the
the
equation,
-1
you have to
too. You
square
can't
the
do that.
entire thing.
Okay.
Now hold on. How would you do this? If you decided to do this, which don't, but if you decided to do this, how would you square this?
I don't think I could because of the -1.
No, you can
Oh
square
no, I could
-1.
because it's not square root. Yeah, I would just square all of it. I would do -1 squared minus y plus 3.
Okay, and then a puppy would die because you decided, oh, I'm just going to square each thing instead of realizing that is -1 minus root y plus 3 multiplied by -1 minus root y plus 3. So you would have to
the puppy
FOIL
would
it.
die.
And
Yeah.
the puppy dies because you didn't do it.
Yeah. Okay, yeah, we won't do that.
We are not going to do that. So we're trying to get rid of everything that's on the same side as y. So I would suggest adding 1 to both sides.
Okay.
That's a good solid step. Now we are going to have to square eventually to get rid of the square root, but this is a pesky negative. So I might, I'm tempted to divide by -1 or just write this as -x minus 1.
Yeah.
Although then when we square both sides, we have to deal with these negatives. So I'm going to take that back. I'm going to go ahead and square both sides now.
Okay.
Because then the negative will go away and that's lovely, isn't it?
Yeah.
Okay, so then we would get, can you do x plus 1 squared for me? Don't kill another puppy, please.
X squared plus x plus 1.
So 2x?
Yep.
Equals what?
Y plus 3.
Good. Hooray.
Yeah.
So we should say that the inverse, you're okay with y, but you should make this statement. Right? And now they also ask stating its domain, right?
Yeah. Yeah.
Okay. So oh, I'm so dumb. Never mind. Okay, so the range, the domain are x values, right? And the range are y values. So you can think of domain as x. And range as y in a simplistic way, yes?
Yeah.
And what do we do when we find the inverse of a function? How do we do that? What's the first thing we do?
We swap x and y.
Yes.
So is it the same thing as the range of the original function? Okay.
Yes.
Cool. Yeah.
Awesome. Now, what does D have in store for us? Find the coordinates where they intersect. Let me see if this is paper 1 or paper 2. It's paper 1. That's awesome, right? So to do that, to find where they intersect, we have to see where they are equal.
Right.
Right?
Could I just graph, like, because I know that I just switch the y and the x, could I just graph it and see if it intersects?
I suppose, but you would have to eyeball it by hand.
Okay, yeah.
Okay.
Better off not doing it. Yeah.
Okay, so yeah, let's go ahead and do this. And I'm going to show it to you to convince you. So
Okay.
the graph of a function and its inverse. Remember, you switch the y and the x, right?
Yeah.
Well, if you have the graph of a function, actually, I'm going to share this screen with you. Don't judge.
Okay.
So escape. Stop share. Let's share. We're going to share two things. We're going to share Google Chrome Desmos, and we're going to share the notebook. Share. Okay, so now you still see the page we were just looking at, right?
Yeah.
Okay. And now do you see the graph?
Yeah.
Okay, so I'm going to graph the original function, which was -1 minus square root of x plus 3, right?
Right.
Okay. Where am I going? Okay. And okay, your lovely face is in my way. I had to move it. Y equals negative, oops. Y equals -1 minus square root of x plus 3. Was that right?
Yeah.
Yep,
That's
there
right.
it is, right?
Yeah.
Looks the same, doesn't it?
Yeah.
Okay. Now, the inverse we found to be, I forget, do you remember? I don't. X squared plus 2x minus 2.
Okay.
And we have to be careful. I'll explain that in a second. I already forget it. Do you remember it? I don't. Plus 2x minus 2. Okay. And now I'm going to graph the line y equals x.
Okay.
Okay, now we have a little bit of a weird thing going here because we say, let me see if I can get rid of it. See if it'll do this. Yeah, it's not going to do it. I'll just do it manually. I don't know how to do it. Okay. Because we said that the domain is from -1 to -infinity, right?
Mm-hmm.
Okay, which is still true. It's just, it has to be that way we didn't set the parameters to not include it because of the original function. We really should have done it. It's okay to just have to have what we have. Let me make sure on the mark scheme. Let me see. There it is. Yeah, we don't have to specify it. That's good. Okay, but on the graph, it'll show up. That's okay. All right, so here's the line y equals x. So the graph of a function and its inverse is a mirror reflection of one another in the line y equals x. Okay, and that makes sense because you're just switching the x's and the y's, right?
Yeah.
So I'm going to take a picture of this lovely thing and maybe try and get rid of the current one. Okay, so see what I'm doing here, huh? Huh?
Yeah.
Not too shabby. So you can kind of see it better.
Yeah.
And you can see it's a better look at how it really is. A reflection, right? You see that?
Yeah.
Okay.
Yeah.
So that's a very important concept. It doesn't have a whole lot to do with this, except for one particular point, literally. And that is the fact that a function and its reciprocal will always, if they intersect, which they don't always do, it will be right here.
Okay.
On the line y equals x, right?
Okay.
So that means both of them share the line y equals x.
Right.
Which means I have a choice. I can take the original function and set it equal to its inverse, -1 minus square root of x plus 3 is equal to x squared plus 2x minus 2, and solve that. Or I can take either one of them and just set it equal to x, which is much, much easier.
Okay.
Right?
Yeah.
Because they all have that point in common. Now I'm going to choose the inverse because I don't want to deal with the square root.
Okay.
Okay, so for D, I'm going to say that x squared plus 2x minus 2 is equal to x, right? X squared, if I subtract x minus 2 equals 0.
Yeah.
Do you know how to solve a quadratic? Do you remember?
Yeah. So x on both best. The outer ones need to equal. So -1 for one of them? No?
It's going to be -2 and plus
-2.
1.
Oh, right. Yeah. That
Because I
makes sense.
need the -2 and the +1 to be a -1.
Okay.
If it was a +1, then it would have been +2 minus 1, right?
Okay. Yeah.
Okay. So x is equal to 2, or x is equal to -1.
Yeah.
Right? Well, the domain is from -1 to -infinity, so this is out.
Okay.
So that means they ask for the coordinate. So that's the x coordinate. So then the y coordinate, I can substitute back into either one of these. I'm going to choose to do this one.
Mhm.
Again, the square root, so -1 squared plus 2 times -1 minus 2. So 1 minus 2 minus 2 is -3, right?
Yeah.
So it would be -1, -3, which certainly, or is that -3? Did I do that right? -1 minus 2, 1. Something's not right. This is plus,
Okay.
plus.
You need another minus somewhere as well.
Yeah. All right. So then we get x equals -2, x equals 1. So this is the bad boy, right?
Yeah.
So if x equals -2, y equals -2 squared plus 2 times -2 minus 2, which is 4 minus 4 minus 2, which is -2. Finally, our world makes sense. -2, -2, right?
Yeah.
Makes sense?
Yes, makes sense.
That is a lot. I'm sure you haven't heard that, anything like that before, but that's a lot of algebra.
Yes.
Literally, because you did a lot of algebra, the whole thing. It's just amazing.
Cool. It makes sense.
I will, as usual, send you the notes.
Okay.
Post the video.
Okay.
My brother Partha. I love you, brother. When you make it big out there, remember me, Partha. Remember me. Remember the little people. And so we're just back on to our Tuesday, Thursday thing, right?
Okay. Yeah.
Okay.
Perfect.
Have a great 5 days. We'll see you on
Right,
Tuesday.
you too.
Stay out of
Bye,
prison
see
over the
you.
weekend, will
I
you?
will.
All right.
Yes, I will. Okay. Bye-bye.